Hi friends, so today we are going to study chapter number 1 of science, chemical reactions and equations. So we have already done part 1 of this chapter, which means that this is the part 2 of this chapter. So we have all, for your kindest information, we have already completed this chapter in shorts, but if you need a whole chapter in one go, so this is the part number 2, and if you have not watched the part 1, please watch it once. So in previous session we have done till balancing. We have covered this all. So we are starting it from here. So in previous session I have given you this as a homework. So I think these two questions were done because they were just balancing and you can do it by yourself. So this here is a theory based question, so let me explain you. So the questions say that why we rub magnesium ribbon before burning it. So here you have oxidation and this is magnesium. So when you have magnesium, so this magnesium when reacts with oxygen, aerial oxygen you may say, it forms magnesium oxide. So we need to remove this magnesium oxide. So now question arises why we need to remove it, because it can interrupt the reaction. So it will be interrupting the reaction, so we need to remove it by rubbing it with sandpaper. So this was all about first question, hope you understand. Moving further, we have types of chemical reactions. So we have learnt during chemical reaction atoms of one element do not change in another element, nor the atom disappear or appear from elsewhere, because the chemical reaction involving breaking and making of bonds between atoms to produce new substances. We will study about this bond in third and fourth chapter. So here they are saying the atoms in a reaction are not changed, they are not appearing, they are not disappearing, but we have bonds. These bonds break to form new bonds. So this is what it's saying in this paragraph. Moving further, we have our first type, that is combination reaction. As clear from the name you can understand, it is something about combining. So here first activity 1.4 we are discussing. We have water and we added calcium oxide to it. It formed slaked lime. What is slaked lime? Slaked lime is nothing else but calcium hydroxide. So here you can see bubbles. These bubbles are of heat, and when you will touch it, you will feel that the beaker is hot. So if we see the reaction here, and it reacts vigorously. So it reacts vigorously to form calcium hydroxide. What is vigorously means actively. You have just added and the reaction started placing place, the beaker started becoming hot, there is a change in color or something else. So we have calcium oxide, which is also known as quicklime. Then we have H2O, which is liquid state, and we form slaked lime, which is calcium hydroxide. So such reaction in which single product is formed from two or more reactant is called a combination reaction. So to explain it, we have element A, B, C, D. So it forms a compound A, B, C, D. For example, I have carbon. When I add oxygen to the carbon, it forms carbon dioxide. So this is one more example of combination reaction. So what is combination reaction? When you add two or more substances to get one product is called combination reaction. This was very easy. So moving further, we have this box. So here they are telling us the preparation of calcium carbonate. Calcium carbonate is also known as marble and it is used for whitewashing. So here they are saying that when we whitewash our walls, after 2 to 3 days it starts to shine. Not on the first day. Why? Because when we that first thing that we are applying on our wall is calcium hydroxide, which is slaked lime. So it takes 2 to 3 days to react with carbon dioxide present in the air, and it forms calcium carbonate plus water. So this water is evaporated and you get calcium carbonate, which is nothing else but marble. So this marble is shiny. Clear? In this paragraph it's just telling you about whitewashing and marble, which is calcium carbonate. So here we have some more examples. So first is burning of coal, which is nothing as carbon plus oxygen gives you carbon dioxide. Then we have formation of water from H2 and O2 to H2 plus oxygen gives you 2 water. So 2 or more substances, elements or compound combine to form a single product in this reaction or combination reactions. So you see the mixture were warm. When you touch the beaker was warm. So what? The heat was released, which means that it is an exothermic reaction. So if you take the term exothermic, you can see exo. Exo means exit. Thermic means heat. So exit of heat means exothermic reaction. So here have you another example, which is burning of natural gas. So CH4 natural gas when reacts with oxygen gives carbon dioxide and 2 molecules of water. So did you know that respiration is an exothermic process? Yes, we knew that, because in respiration energy is released. You take in food, you convert it into energy, which is ATP. So there is a release of energy. See, we can see that these carbohydrates are broken in form of glucose. Glucose combined with oxygen in our cells and provides energy. Special name of the reaction is respiration. So we'll be discussing this respiration in our chapter number 6, life processes of bio. So if you're watching this session, you can comment down which chapter you want to watch next, like from science or any other subject of yours, except any language subject, but you can ask for English. We have glucose. When it reacts with oxygen gives 6 carbon dioxide, 6 water and energy in the form of ATP. So then we have decomposition of vegetable into compost is also an example of exothermic reaction. So now you understand here what is decomposition. So haven't you noticed that what is an exothermic reaction? Exothermic reaction means exit of heat. If there is exit of heat, which means that beaker will become hot. Then you have decomposition reaction. First we have this activity. So wafting gently to all snows, boiling to ferrous sulfate crystals. So we are burning ferrous sulfate. When we'll burn it, we'll get ferrous oxide plus sulfur dioxide plus sulfur trioxide. So here, and you will be heating the boiling to contain crystals of ferrous sulfate and a smelling atom. So these two gases smells really bad, and you can get this smell when you will be smelling it. When you will take that test tube, don't take it too near, but if you'll be like putting and waving your hand towards your nose, you can get a little tint of what that is. So we have ferrous sulfate, when given heat gives you ferric oxide. So this is an example of thermal decomposition reaction. So when we talk about decomposition reaction, we have three types in our syllabus. First is thermal, second is electrolytic, and third is photolytic. So decomposition means that you have an A, B, C, D molecule, and when you give it an energy, it breaks into its consequents like A plus B plus C plus D. So this is what is decomposition reaction. So this reaction you can observe the single product breaks down into simpler products. This is decomposition reaction. Sulfate crystal Fe2H. This is water of crystallization. Loose water when heated and the color of crystal changes. And you get ferric oxide, sulfur dioxide, sulfur trioxide, and ferric oxide is solid, and these two are gases. So now we prepared calcium carbonate, right? So now we'll be decomposed. So when you will give it heat, what you will get? You will get nothing else but quicklime and carbon dioxide. And carbon dioxide. And this is your reaction, this is explaining, and this is example of C. When a decomposition reaction is carried out by heating, it is an thermal decomposition reaction. So then we have another example. You have a test tube holder, a boiling tube, lead nitrate, and a burner. So now we are burning lead nitrate. So then we have this reaction. If you see the reaction, we have lead nitrate, which is PbNO3 twice. It breaks into lead oxide, nitrogen dioxide, and oxygen. So here also we can say it is a thermal decomposition reaction. So hope thermal decomposition is clear. Moving further, we have electrolytic decomposition reaction. Here first example is of electrolysis of water. So I took a battery and it is cathode and an anode too. So anode is that part which is connected to the positive terminal, and cathode is that part which is connected to the negative terminal. So you have graphite rod here. So instead of graphite rod, you can use it pencils and a iron nail. So what you will observe is that on the positive side, in outside, you will be getting OH negative ion deposited, and on the negative side you will be getting H positive ion deposited. So this is water here, hydrogen on negative terminal and oxygen on positive terminal. So in plastic mug, so this is electrolysis of water. This is important part. This is an important thing, so keep in mind. And one question comes from here is that 2:1. Why hydrogen is collected twice of oxygen? Because you have H2O. In one H2O, you have 2 hydrogen and 1 oxygen, so which means that it will be collected in the ratio of 2:1. Clear? So this was electrolytic decomposition reaction. So definition is not given, so let me write it here. Reaction in which a substance is decomposed by electricity is known as electrolytic decomposition reaction. So now we have this experiment. So here I was having a white colored silver chloride, but when I put it into the presence of sunlight, it changed its color into silverish color. Why does that happen? Because silver chloride in the presence of sunlight breaks into silver plus chlorine, and silver is of grey color, so this is the color of silver here. The reaction is 2AgCl2 solid when in presence of sunlight breaks into 2 silver element of solid and chlorine gas. Clear? So this is all about it. So you see the white silver chloride turns grey. If I write the definition now, when a decomposition reaction is carried out by sunlight is called photolytic decomposition reaction. Clear? DR means decomposition reaction. You can write on the space with NCERT like me because it's easy to understand then. So then you have one more example, which is silver bromide in the presence of sunlight breaks into silver and bromine. So this is also one important question right here. Which of the following substances are used in black and white photography? The answer will be AgCl2 and AgBr, which is nothing else but silver chloride and silver bromide. So you have seen that a form of electricity for breaking down reactants in which energy is absorbed is known as. So now I can't focus on that word, let me write it by myself. So you have a word here, endothermic reactions. So what are endothermic reactions? They are nothing else but opposite of exothermic. See, you have endo. Endo means in, thermic means heat. When heat is absorbed, it is known as an endothermic reaction. Don't you think that decomposition reactions are endothermic because they are all taking in energy to decompose? Means that all decomposition reactions are endothermic reactions. So now I will tell, don't you think decomposition is opposite of combination reaction? Because here the same thing is breaking, in that thing the same thing was combining to form that product, and now that product is given energy and it's breaking. So which we can conclude here, decomposition reaction is nothing else but opposite of combination reaction. Moving further, we have these questions, these are your homework for today, okay? Then we have displacement reaction. So activity 1.9, we have stand, test tube, thread, copper sulfate solution and iron nail. So when this reaction will take place, copper sulfate plus iron, you will see the formation of FeSO4 plus copper. So after some time you will see here something is deposit. There is some deposition of something. So it's nothing else but iron sulfate. So this was only this reaction explaining part. I think in NCERT is given, okay. So we iron nail taken out of copper sulfate. This is a layer of copper. copper sulfate solution, test tube stand, reaction mixture, test tube. So this is test tube B, and this is test tube A. In this copper sulfate is blue in color, and this is ferrous sulfate, which is almost white or transparent, you may say. So sorry, I told you a little wrong. So this deposition is of copper. Okay, please don't spread it. Okay, then we have Sc plus copper gives you iron sulfate plus copper, and other examples are zinc plus copper sulfate. Zinc forms zinc sulfate plus copper. Lead plus copper chloride gives lead chloride plus copper. So zinc, lead are more reactive than copper, the display. So now one question. So let me explain you with it. I have an AB salt solution. When I add C, it forms BC, and A is displaced. So here A is displaced from its compound, you may say, or salt solution, you may say. Compound or salt solution. So what happens here is that why does it can displace? Because it is more reactive. When it is more reactive, it will be displacing it. So how to know that one thing is more reactive or it is less reactive? So I'll be uploading a short on this topic, which is reactivity series, and I'll be telling you a method to remember it. So wait for that video. Okay, clear? Because if I'll be explaining it here now, it will take too much of your time. Then we have double displacement reaction. So we have test tube containing sodium sulfate plus barium chloride. So what it will be forming? It will be forming barium sulfate plus NaCl. So this will be the reaction. So in previous we talked about single displacement reaction. Here we have double. Here will be interchanging of ions. So you will observe that which insoluble in water is formed. Insoluble substance formed is snow. So here you will be getting a precipitate, which is nothing but an insoluble substance. Nothing but an insoluble substance in water, which will be collected, and they are also called precipitation reaction because of the formation of precipitate in them. So white precipitate of BaSO4 is formed by reaction of sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ion between the reactants are called double displacement reaction. Double displacement means ions are getting exchanged. Okay. Then we have our last type of reaction. Finally, that is oxidation and reduction reactions. So I have a china dish containing copper, wire gauze, tripod stand, and burner. So this is oxidization of copper to copper. So this is copper. When I am adding oxygen, it will form copper oxide. So this is oxidation. Oxidation meaning is gain of oxygen and loss of hydrogen. Reduction is opposite. It is loss of oxygen and gain of hydrogen is known as reduction. So after this reaction, you will see black copper oxide. So this is the reaction when given heat forms. So don't you think this is also an example of decomposition reaction? Very good. Combination reaction. So we can conclude here that not all combination reactions are exothermic. Then hydrogen gas is passed the heated material. The black coating turns brown and reverse the reaction. So now if you add hydrogen, it will form copper plus water. So this is also an important question in previous examination has come, that redox reactions are reversible. Yes, they are reversible because it's nothing but addition, or like you are removing something. If it will be added again, then it will be reversed. See, copper oxide plus hydrogen, this is reduction, whereas H2 is getting oxide. See, copper reduce because oxygen loss is there, and H2 get oxide because gain of oxygen is there. So now they will be asking, there is hydrogen addition also. Why it is not known as reduction? Because first we will take about oxygen, then we will take the case of hydrogen if we are not getting oxygen. Example is zinc plus carbon. Zinc oxide plus carbon gives zinc plus carbon monoxide, and other examples. So in this reaction, carbon is oxidized to give carbon monoxide and zinc oxide is reduced to zinc. HCl is oxidized to Cl2, whereas Mn2 reduced to MnCl2. So here we are done for the day, and then we have corrosion and rancidity. So corrosion is nothing but eating up of metals. Like we see in magnesium, there became a layer of magnesium oxide. So layer can be harmful for the metal or it can be protective. Like in the case of iron, let's read it now, okay. The process is commonly known as rusting of iron. Some of the other metals get tarnished in this manner. When a metal is attacked by a substance around it, such as moisture, acid, it is said to be corrode, and this process is called corrosion. The black coating on the silver and green coating on the copper are example of corrosion. Corrosion caused due to damage of car bodies, bridges, iron, and other, especially those of iron. Corrosion of iron is a serious problem. Every year, enormous amount of money is spent on replace damaged iron. You will learn about corrosion in chapter 3. So rancidity. Rancidity is nothing but oxidation of food. When there is oxidation of food, there is change in odor and taste, which leads to food getting rotten. The correct word is rotten, not. So now there will be some ways to like added to food. Antioxidants, you can add antioxidants to prevent rancidity, and you can also put in airtight containers, and you can also use flush bags in which you will be adding nothing but nitrogen gas, because nitrogen gas is inert and very less reactive. It doesn't react with a material. So this is also your homework. These questions will be discussed if you want me for an NCERT in one short session, in which we'll be discussing all the questions of NCERT. So this was all for today. We have covered the types of reactions and corrosion and rancidity. Thank you. Hope you understand.